Hey everyone, today we're going to learn about factoring some simple polynomials. First thing I'd like to ask you are, what are the factors of 15? And you notice that they're 1, 3, 5, and 15, and you should also notice that they come in pairs. I asked you this before I even talked about what factors are. You notice I gave you the definition that factor is any number that multiplies to get you the original number. So 3 and 5 multiply to get you 15, and 1 and 15 also multiply to get you 15. That's also a good way to check later on when you're factoring monomials or binomials to make sure that you have all the factors. So let's try this one right here. What are the factors of 4x? Well, there's 1 and 4x because those multiply to get you 4x. There's 2 and 2x because those multiply to get you 2x. And then there's 4 and x because those also multiply to get you 4x. I don't like how I listed them here, but I wrote them this way so that you could see which multiply to get you 4x. I much prefer writing them this way, so let's try the next one. The factors of 3x squared are 1 and 3. Notice I wrote down all the factors of the coefficient first. And then there's x, because you can multiply x times 3x to get x squared. And then there's also x squared and 3x squared. Notice I wrote down the coefficients first so I could list them all in order. You don't have to do it this way, but I just want to double check and make sure I listed them all. So what I'm going to do, one way to check that, is to underline which ones go together to multiply to get you 3x squared. So 1 and 3x squared multiply together, 3 and x squared, and x and 3x multiply to get you 3x squared. Let's do one more together. It gets a little more complicated. You notice the factors of 5ab squared are all of these, and I'm going to go through and just check real quick to make sure I got them all. You can kind of see a pattern in there. Notice with the coefficients always have 1 and 5, and so that pattern repeats over and over. And a common thing is to miss one of these, but if you go through and check, you should be able to easily identify which one you're missing. So let's just make sure. You got 1 and 5ab squared, 5 and ab squared, a and 5b squared, and I'm going to start using the same colors here because I'm running out of colors, 5a and b squared, b and 5ab, and then 5b and ab. And notice if I had forgotten, say, the b squared term here, if I'd forgotten that, then when I was going through and listing, I would have wondered, well, what does 5a multiply with to get 5ab squared? And I would have found it out and remembered it. I'd like for you to try this last one on your own. This is just a tad harder, and you can pause the video here and answer this question. All right, hopefully you got that question right. So what we're going to do is we're going to move on to factoring binomials. They look a little different, so let me show you. All right, let me ask a question. What are the factors of 3x plus 9? Well, if I told you that 3 and x plus 3 are the factors, hopefully, after some thinking, you'd realize that, oh, if we multiply those together, we can get 3x plus 9. Let's do just that. So I'm going to multiply 3 times x plus 3 and distribute it, and you get 3x plus 9. And since a factor is just anything that you multiply to get the original number, then we just have to multiply those two together, and you see, hey, those are factors. So when I say to factor 3x plus 9, you don't have to write them out separately like that. You just have to write them, you can write them multiplied together just like this. So if I say factor 3x plus 9, you can say 3 parentheses x plus 9. Let's try the next problem together, and I'll go and show you how I got those numbers. So when I say factor 6x plus 9, what I'm first asking is, what is a factor, what number is a factor of 6x and 9? Well, I see that 3 goes into both of them. So once again, I'm going to try to take a 3 out. I'm going to pull the 3 factor out of each of those. And when you do that, you get 3 times something. And that something, what's left over, is going to be 2x, because that's 6x divided by 3. And it's also going to be 3, because 9 divided by 3 is 3. You can double check, and I would recommend doing this every time. You can double check by multiplying it back out. So 3 times 2x is 6x. And 3 times 3 is 9. A lot of people call this undoing the distributive property, and that's exactly what it is. We're simply undoing the distributive property when we're factoring binomials like this. Let's try one more just to make sure we cover all our bases. So if I ask you to factor 4x plus 8, many of us would go, oh, look, there's a 2 that goes into both of those. And you would be correct. You can pull a 2 out, so we get 2 parentheses, 2x plus 4. However, this is not fully factored, okay? Because if you look inside the parentheses, we could take another 2 out, because 2x is divisible by 2, and 4 is also divisible by 2. It is perfectly fine for you to write this step in here as long as you continue on and fully factor it. So we need to write down, by taking another 2 out, we get 4 on the outside, parentheses, x plus 2. I know you could write 4 as 2 times 2, but written like this, with the 4 all as one term, that's how you want to write it when I ask to fully factor it. So we have 4, and then parentheses, x plus 2. Notice down here in this diagram, I have 3 different levels. The simplified is what we start with, and sometimes, in the past I've asked you, hey, take 4x plus 2 and simplify it, and you want to write down 4x plus 8. That middle term, 2 parentheses 2x plus 4, that's not going to be a right answer to any problem. So you want to make sure you either have it fully factored, or if I asked you to multiply it, that you simplify it all the way. The number 4, we have a special name for that, because this number 4 that we pulled out of 4x and 8, that's called the greatest common factor of 4x and 8. And if we break that down a little bit, it's a factor because it's a number that multiplies to get 4x and 8. And it's also common because it is a factor of 4x and of 8. And it's the greatest common factor because it's the biggest number that goes into both of them. So let's do a few practice problems here. I'll do this first one with you, so you can already see I did 5 is the greatest common factor, so I want to write that down right there. GCF is just a shorthand notation for greatest common factor. So 5 is the greatest common factor, so I'm going to write 5 parentheses x plus 2. That's what is left over when you use the distributive property. And to check, I'm just going to do that. I'm going to use the distributive property. So I'm going to multiply the 5 times the x and the 5 times the 2, and I get 5x plus 10. Let's try a little bit harder problem. So you see there's another variable in here. So I'm thinking, and I'm looking, and I know that the greatest common factor would include 5, but also includes the variable a. Because when you multiply that out, you can divide both the first and the second term by a and have a whole number left over. So you notice the factor is, once we factored it, we get 5a parentheses 7 plus 2a. And to check, let's just multiply that back out. So I'm going to multiply 5a times 7 and 5a times 2a. 5a times 7 is 35a, and 5a times 2a is 10a squared. You notice I've checked and made sure that I've multiplied that out correctly. Go ahead and try these 4 before coming to class, and what we're going to do is we're going to, once we get to class, you're going to share your answers with your classmates and work out any differences, hopefully learning from them and also teaching them as you go through this. I hope you learned a lot about factoring in this video, and thank you for watching.